so we're going to solve this trig identity. So let's begin. To begin solving trig identity, you got to notice both sides, right? You got to notice your left hand side and you got to notice your right hand side. You got to see which one's harder, because if it's harder, it means, if it's harder, by that I mean like if it has more things, right? Then the more things there are, the more uh, operations we're able to do onto them, essentially, right? Then something single. For example, if it was like sine squared x plus cos squared x is equal to 1. 1 is a very simple thing. We can't do much to it. Whereas this, right? It's two things. It's more things, right? So we can do more operations on it, basically. So with this, you guys probably know this is just 1. So 1 equals 1. Proved. So that's what I mean by choosing something with a lot of things on it. So which side has most things on it? I noticed that the left hand side has a lot of things in it: cotangent and tangent, right? Whereas the right side is just one term. So let's begin with the left hand side. What do we know about cotangent theta and tan theta, right? We know cotangent is 1 over tan theta plus tan theta, right? So we're adding a fraction to a whole number. This would be like a whole number. This is 1 here, implying 1. So how do we do that? First, we get the same base. This can also be written as tan over 1. So to get the same base, we just multiply by tan theta on both the numerator and the denominator. So in that case, we get 1 over tan theta plus tan squared theta, because remember, this is tan theta. If I told you it was x times x, you would say it's x squared, right? Same thing as here. This is equal to tan squared. This is over tan theta. So now, since we have the same base, we can add the numerator having a common base of tangent theta. So we get 1 plus tan squared theta all over tan theta. Right. So that is that. Now, what do we notice? We notice this numerator on the top is another identity. This is the secant squared identity. So we can replace this by secant squared theta over tan theta. Theta, right? If you don't know that, or if that's not in your formula sheet, let me just derive it for you. You 1 plus tan theta squared theta. This is equal to 1 plus sine squared theta over cos squared theta. Get the same base again, so you have cos squared theta. This is 1 multiplied by both sides by cos theta, so you get cos squared theta. So you get cos squared theta over cos squared theta, which is again just 1, right? Plus sine squared theta over cos squared theta, and this is cos squared theta plus sine squared theta all over cos squared theta. This top becomes a 1 over cos squared theta, which is the same thing as secant squared theta, right? So that's my little proof for it, if you didn't know. But moving from there, we can just replace it by secant squared theta, right? Now, tangent theta and secant squared theta hold more properties in it. We can introduce new identities on them, right? Tan theta can be written as sine over cos, and secant squared theta can be written as 1 over secant squared theta, right? This is just me simplifying things. So it's 1 over cos squared theta, as I just proved earlier, and this is sine theta over cos theta. So this now becomes 1 over cos theta. When you're dividing right fractions, remember you gotta flip and multiply, change the sign. So this becomes the numerator, you keep it the same, then you change the sign and you flip the denominator, which is cos theta over sine theta. Cos and theta and one of the cos squared theta cancel out, so we have 1 over cos theta sine theta, right? So is there anything more we can do to this side? This is the maximum we can do to the left side, right? This is the simplest form we can get it at. So this is when now you move to the right hand side, because we can't do anything else to the left hand side. We deduced that the left hand side is equal to 1 over sine theta cos theta, right? Same thing as there, just rewriting the denominator. So if that's the left side and we can't do anything to it, what do we have left? Now we have the right side left. So let's move on to the right side. When proving trig identities, you can interchange between two sides, right? So you can simplify one side to make it simpler and see what you have to do for the right side to make it equal to the left side, if that makes sense. But again, we can't do anything more to this. So we move on to the right hand side. What is right hand side? We have 2 cosecant 2 theta. What is cosecant theta? CSC theta is equal to 1 over sine theta, right? Or CSC x is equal to 1 over x. The reason I did that is because there's 2 in here. We can take x to be anything. Let's take x to be 2 theta, because that's something we have inside CSC, right? So in that case, if x is that, then CSC 2 theta, remember this is x, I'm just subbing it in, is equal to 1 over sine 2 theta. X is just being subbed in. So this can be written as 2 times 1 over sine 2 theta, right? And distribute the 2 in 2 over sine 2 theta. Now, how can we simplify this? Remember, we couldn't do anything here because there's no more identities we can use. Nothing else we can make this simpler. But in this case, we can make sine 2 theta simpler, right? This is a double angle formula. This says that sine of 2x is equal to sine 2 sine x cos x. Okay, so what is x in this case? X is theta, and using the double angle formula, we get 2 over sine 2 sine theta cos theta, right? I'm just using a double angle formula here. So what does this become? 2's cancel. This becomes 1 over sine theta cos theta. And does that equal left hand side? Yes, it does. So left hand side equals right hand side. I'm used to the real numbers. Right hand side. Therefore, Q E D.